Hello and welcome. Today we are talking about compound probability and Venn diagrams. So to recap, we talked a little bit about compound probability in our previous video. There we talked about compound probability as the probability of multiple events happening together. We said that the probability of A and B means we're looking for an outcome where both events happen at the same time. We said the probability of A or B means that we're looking for an outcome where either one of the events occurs, but not necessarily both. The probability of A given B is something new. This simply means that we're looking for the probability that event A happens, given that we already know that B has happened. When we're looking at the notation, the symbol for OR just looks like a capital U. The symbol for AND looks like a U that's been flipped upside down. And we're looking at given, the symbol is just a straight line. So this would read as the probability of A and B. This says probability of A or B. And this guy says probability of A given B. Next, we're going to look at Venn diagrams. So a Venn diagram is a good way to help us organize a sample space of compound events. So we have one circle per event, and the section where the circles overlap represents outcomes where both events happen simultaneously. This space right here represents outcomes where only A happens. Here is where we have outcomes where only B happens. And if there's a possibility of neither happening, then that would be represented by things outside of either circle. And so now we'll look at an example of a situation where we might want to use a Venn diagram to help organize our information. So we've given a survey to a series of students. One question asks whether or not the student is a vegetarian, and another asks whether or not the student has a tree nut allergy. We have 50 total students surveyed. 8 stated that they are vegetarians, and 3 stated that they have nut allergies, while 1 represents both. To begin, we'll go ahead and make 2 circles. The first will represent students that are vegetarians, and then the second will represent students that have allergies. From there, we'll go ahead and put 1 in the middle to represent the one student that is both a vegetarian and has an allergy. From here, we can fill in the vegetarian circle so that there's 8 students in total, including the one that we've already placed in the middle. So if we take the 8 vegetarians, subtract out the one that's in the middle, that leaves us with 7 vegetarians that do not have a tree allergy. So we'll go ahead and put the 7 right there. We can then do the same thing for the students with allergies, once again subtracting out the one student that is also a vegetarian. So if we have this filled out correctly, we have 7 students that are vegetarians only, 2 students that have allergies only, and 1 that has both. The last thing that we need to be aware of is that there were 50 students in total. The last thing that we need to look at is the total number of students. So because there were 50 students surveyed in total, the numbers in the Venn diagram should add up to 50. So if we add up the numbers we have so far, 7 plus 1 plus 2 is 10, which means we have 40 students remaining who do not fit into either circle. So now let's take the data that we just organized and use it to calculate some probabilities. Our first question asks, what is the probability that a randomly selected student is a vegetarian and does not have a tree allergy? So we're going to start by writing it out using our mathematical symbols. So the P is for probability, the V for vegetarian. We said this symbol means and. A is for allergy, and this little tilde means not. So you can almost think of this like the probability version of a negative sign. So using the Venn diagram as our sample space, we can start by finding the number of students that were vegetarians but did not have an allergy, which is going to be these 7 students right here, because they are inside of the vegetarian circle, but they are not inside of the allergy circle. To fill in our denominator, we just need to write down the total sample space, which in this case is 50, because once again, there were 50 students surveyed in total. So the probability that a randomly selected student is a vegetarian but does not have an allergy is 7 out of 50. Next, we will calculate the probability that a random student is a vegetarian or does not have a tree nut allergy. Since this says or, we need to make sure that we include any student that matches at least one of the 2 conditions. So we'll include the 7 and the 1 because these students are all vegetarians. We will also include the additional 40 students out here because they do not have a tree nut allergy. So the only students that we don't need to include are these 2 right here because they are not vegetarians and they do have the tree nut allergy, so they do not fit either of these 2 conditions. We'll once again use 50 as the denominator since that's our total sample space. And then we'll just simplify our work to get 24 out of 25. So the probability that a student is a vegetarian or does not have a tree allergy would be 24 out of 25. And finally, we will calculate the probability that a randomly selected student is a vegetarian given that the student does not have a tree nut allergy. So this is what is called a conditional probability, which means that we are changing the sample space to only include students that meet the given condition. So because it says given that the student does not have a tree nut allergy, our sample space will only include the students that do not have tree nut allergies. So my sample space should include these 7 students here, as well as these 40 right here. Out of those students, only these 7 here are vegetarians. Therefore, the probability that a student is a vegetarian, given that the student does not have a tree allergy, is 7 out of 47. And that's all we have for this one. I'll see you guys next time.